Hey guys, so in this video we're gonna discuss Leetcode 2096, and this is the very common coding question asked in Google and Amazon interviews. So for this problem, we're gonna be given the root of a binary tree. So a binary tree will be a tree has like every node will have maximum two child nodes, the left one and the right one. And every node will assign the value from 1 to n, right? And we're going to be given an integer, which means the start value, and an integer, which means the end destination value. So we need to find the shortest path from the starting node to the ending node with step-by-step directions to get there. So the directions can be L means going to the left child, R going to the right child, and U going to the parent node. So for example, in example one, if we want to go from the node 3 to node 6, then we're going to go like up, right, and left. So the return will be UURL. All right, so for this problem, we're going to be given like the starting node and the destination node plus the root node of the tree, right? And as we have discussed before, to find the shortest path of something, we need to use BFS because BFS travels layer by layer, and we're gonna find the minimum number of steps moving from the starting status to the ending status. So for this one, since we are given the binary tree as the root node of it, so we need to traverse through the tree to generate a graph so that we have the graph, and then with the graph we can do the BFS on the graph. So we need to traverse through the entire tree two times. The first time is to build up the graph, and the second time is to use BFS to find the minimum number of steps. Okay, so let's get started. All right, and the same as before, I need to use a DQ for the BFS. All right, and then first of all, I need to generate the graph from the binary tree. So I also need the default dictionary. So for the graph, usually I just need to generate a graph with the default dict with value of list. Sorry. All right, so and I can do a DFS through the tree to build up the graph. So let me just define the helper DFS function. DFS node if node dot left. So if it has a left node, then the graph be the node. So the node will have the left child would have the left node, right? Graph would append the child node would be node dot left dot val node dot left dot val, and the direction would be moving left, and we're gonna append the left node to node dot left dot val node dot left dot val. It will append the parent node to it as well. Up. Sorry for typo here. Append. Right, and then I'm just gonna recursively loop on the left node. And the same for the right one. And right. So the right one would be R. The right one will have a upper one will be the node val and the DFS on the right. Yep, makes sense. So now let me just build up the graph by doing DFS on the root. So now this will build up the graph. Build the graph. All right. So then we're gonna use the BFS. So BFS to find shortest path. All right. So let me extra space. So we need a Q, QUE, DQ, and the visited set. Visited set. And the initial status would be Q dot append the starting node with the start value. And I need to keep track. I need to also keep the return string, like the return string inside the status, so that I can just return directly once I reach the destination value, and I can keep appending the moves to this. So it will be every item would be the current position and the current path. The comment here. And also the visited at the current starting value. Now we can start doing BFS while Q, so the current position and the current path would equal to Q dot pop left. Right, so this is the current position and the current path. So if now we need to define the exit status. If current position, it's all camel case. Let me just make it camel case. Sorry, my bad. Current position equal to the destination value, then return the current path. Otherwise, we can visit all the children so every node will have the child node for child direction in G of the current value, current position. If child not in visited, only visit that if it's not visited before. Visited dot add the child. And also you can have the Q dot append the child plus current path plus direction. Otherwise, if we never reach the end, actually we will always in case the input is invalid. So let's just return an empty string. Let's see. And then see how it goes. Yeah, so it works fine. So yeah, so for time and space complexity, so since for time and space, we visit every node twice, so it will be time will be order of n. And the space wise, we visit, yeah, so we keep track of the queue and the visit set, so it's order of n as well. All right, so this is the end of the video, and I'll see you guys in the next question.